Okay, let's try this here. If I just click over here and then come back. Okay, that one keeps on going. Okay. Sorry guys, I'm having a heck of a time with this computer thing and the camera and stuff. It's just being a real pain in the neck. So I gotta do this all over again. So trip number 4 is the camera stopped when I actually shrunk the window as I was trying to do everything else. So I'm just gonna go back and forth here. Try this again. As I was all the way up to question 12. Okay. So, what diameter electrode is acceptable under those in the WPS SMAW2 and PQR2? The answer is, as everything goes through A, B, C, D, and E, the answer is going to be E. As if you look through document 7 and 2, they show 1/8 inch on the PQR and 1/8 inch and 3/32 in the WPS. Both are acceptable even though one does not say the 3/32. You use both of them. Can a welder use carbon-molybdenum type metal per WPS SMAW2 and PQR2? Well, as we go through our answers and you read them, you have where it's not considered essential, specify what type of metal is used, was not done. Actually, it is, just not in the question. Change the type metal is not considered a variable change. The F number is not allowed. The A number is not allowed. So you have a bunch of different variables that you can choose from. But if we go back and look in the with our electrodes, the A numbers, what is on the blueprint is M131. 31231. Sorry, I'm saying material number 1, 3. As you can tell, I mean, doing this is kind of getting to me as I've been trying to get this whole camera thing figured out. So it's 3131 on both blueprints. Say the same thing. The 1 is a low carbon electrode. 2 is a what the heck do they call it? I'll make sure I get it right. Carbon molybdenum electrode. So they say I want to use this. It's not on the blueprint. They cannot use it. So the answer is E. No, this is a different A number than was allowed on the WPS. Now it says here both the WPS and PQR show a weld metal analysis A number per A number 1. Per Annex 1 of the BOS, A number 1 is a low carbon type weld metal and carbon molybdenum is an A number 2 type metal. The change in filament metal A number is not allowed per 5.2.3.3.2 table 8. Question number 3 is using WPS SMAW2 and PQR2, what combination of base metals can be welded together? Well, they threw in some pipes on this one. So you literally have to look at the question, go through your paperwork here, get into your apex of base metal specs and M number tables. And what you find out is API is the pipe going to plate. You have 2 different grades of plate. And then you have a grade 4 which cannot weld to a grade P12. So the only option is exactly what is showing is see, number 5, document number 5. Let me double check here. Oh, that's number 6. Oh, that was close. So is the ASTM A369 grade FP1 to ASTM A369 grade FP1. So same metal welded to each other. Number 4. Are the minimum preheat and maximum interpass temperatures listed on WPS SMAW2 acceptable to per PQR2 assuming fracture toughness testing required. Now, what you're looking at is going between both pieces of paper of document 2 and number 7 and looking at the preheat and interpass temperatures. Now, if you go to table 8, 5.2.3.4, it's going to show you that on the preheat can be within 100 degrees and the interpass can be between 100 degrees. Now the PQR2 is 200 degrees. WPS is 150 degrees, within the 100 degrees. Now the max interpass temperature on this is 500 degrees on the PQR, 600. WPS is 500, still within 100 degrees. Now if it was like 601 to 500, it would fail. It would list under the whole maximum interpass temperature too high, because it's not within tolerance. Or you could go with the minimum preheat too low. So I mean, but this is not the case. As the explanation below is, WPS Mod 2 has a minimum preheat temperature of 50 degrees F Fahrenheit lower than PQR2 and a maximum pre-interpass temperature that is 100 degrees lower than PQR2. Both of these changes are within the acceptable limits of table 5.2.3.4. So it's A, minimum preheat acceptable, maximum interpass temperature acceptable. Now, mind you, these can change. They're not going to list them just like this. These are all practice tests. In this alone, there are 45 questions and 3 tests. That's 135 questions. And that doesn't include what you study in the little practice tests. They're like 25 questions long. And there are almost 10 of those. So you're looking at a lot of questions put all together right here. Now, question number 5. A welder uses WPS too small and has a travel speed of 8 inches per minute, 5 amps, 26 volts. Are these variables acceptable? Well, we have travel speed acceptable, amperage acceptable, voltage acceptable. Travel speed acceptable, amp too low, volt acceptable. Travel speed acceptable, amp acceptable, voltage too high. Travel speed too low, amp too low, voltage too high. Travel speed too low, amperage too low, voltage too high. Well, when we look at this off of the documents, it shows that our travel speed is between 5 and 10. So it's acceptable as it's an 8. 75 amps, amperage is from 75 to 125. So it's at the bottom, but it's acceptable. 26 volts, the WPS says 20 to 25. 26 volts is too high. So we have travel speed acceptable, amperage acceptable, voltage too high. Explanation it also says, although these variables in WPS small 2 don't match PQR exactly, they are essentially variables that violate table 8 parameters. Both the travel speed and amperage comply with the WPS, but the voltage exceeds the WPS requirements. So C. Number 6. Do the test results shown in PQR3 correctly qualify WPS small 3? Oh, rubber band broke. Okay. Now, the max tensile strength for this is 78,000 PSI. So, see, number 10. Let me double check that. I looked at the wrong one. Table 8 becomes your best friend. In the 8 and 7 in this becomes your best friend. So we have it 78,000 PSI tensile strength though. Specimen number 1 was 79,940. It passed. Spec 2, 77,880. So it failed. So we already know that out of all of our questions that were anywhere from that they are all acceptable. The PS was written by CWI, wrong type of bends, constraints not met, and then we have C and D. We already know that C, the wrong type of bends were used. Oh, sorry. Right. Tensile tests do not meet the requirements. Now we look at the guided bend tests. Both roots were acceptable, both faces were acceptable. This was 1/2 inch steel. Anything over 3/8 a 1/2 inch, you cannot use face and root bends. You have to go with side bends. So even the side bends are not acceptable. So C and D. Let me check something. Okay. Make sure everything's still kosher on that. Okay. Now we have, what is the minimum allowable bevel angle per GMAW3 for a double bevel groove weld? Okay. So, as I'm looking at the little print here, a sketch of the joint, one is at 90 degrees, the other one is double bevel with a 40 degrees plus or minus 5. What is the minimum allowable bevel angle? So what's 5 minus 40? 35 degrees. So 35 degrees is the answer. Which of the following variables on GMAW3 are not allowed based on PQR3 in the BOS? Now, this one threw me for a loop, but the possible answers are: not all weld positions are allowed, polarity is incorrect, travel speed too high, shield metal gas, and mode of metal arc transfer. Well, the metal transfer is short arc. The travel speed is within tolerance. The polarity is DCEN, which is, DCN. And the weld position is 2 and 3G, so not all weld positions are allowed. So when you just take out those 4, you only have 1 left. And it is the shielding gas composition is incorrect because on the PQR3 it says 75% argon, 25% CO2, and the other one says 100% CO2. Now everything you can change up a little here, a little there, as long as it's within the spec of the variables, except for shielding gas. It has to be the same. As an answer explanation is, there are several variables on WPS GMAW3, but that are different than the variables in PQR3, but the changes in the shield metal arc composition are the only variables that violate table 8, 0, 5, 52362. The mode of metal transfer is the same as PQR, but all the other variables can be changed without requalification. But the shielding gas is what will get you every time, apparently. Which of the following base metal combinations can be used? WPS, GMAW3, and PQR3. Well, as we go through, you're looking at all your base metals. You're going to look at the first metal, A533 type B, class 1 to ASTM A516 grade 70, as well as there is one that is same first, but it's a class 3, but it's ASTM A204 grade. Now, class B3 cannot weld to grade A as they are different M numbers. The 1-inch ASTM A36 to API 5I grade X60 is one is plate, one is pipe. ASTM 204 grade C to ASTM type A240 type 410. Those are different numbers as well. They're different categories. 3/4 inch thick ASTM A36 to ASTM A225 grade C. Again, it's not going to match. So your only acceptable answer is going to be the ASTM A533. Type B Class 1 to ASTM A516 grade 70, as they actually had the same M number or allowable in the number, M1 or M3. The other ones did not match either. It was like it could be a 1, 2, 3 with then they have a 2, which is not allowed, or it could be a 2 and a 2, not allowed, as the second number is a 1, and it's not allowed unless that both those numbers are actually 1 or 3 or a 1 in the next column. So it says both ASTM A533 Type B Class 1 and ASTM A516 grade 70 belong to either M number 1 or 3. This arrangement is allowed per section 5.2.1.11. Other metals belong to M numbers 1 or 3 but include a pipe product. This is not allowed per WPS. Number 11. Let's see. Which of the following carbon content is acceptable in the filler metal when using WPS FCA W1? 2.0, 0.20, 0.50, 0.15, 20.4. Now the WPS FCA W1-1 specifies the weld metal to be F number 6 and A number 2 per annex of the BOS. A number 2 has a chemical composition of 0.15. Now when you do this, you're looking at the document 1 and 6 and flipping over to the filler metal, which is number 7, I believe it is, table 7, and it's asking what's the carbon content. Well, you're looking at which electrode is going to be used. Filler number 6, weld analysis number 1. Okay, so if you look at number 6, it's 0.15. So 0.15 is your answer. What welding positions could be qualified in a WPS using PQR-1? Well, you have flat, horizontal, and groove, flat, flat, and horizontal, fillet, flat, vertical, horizontal, and all. Let's see here. The answer on this one is all. And the explanation is changing the welding position is not an essential variable change listed in Table 8. Therefore, a new WPS could be written from PQR1 using any weld position, even though that the PQR test pieces was done in the flat position. So, yeah, it's done in the flat position. Does not mean it's necessarily on a change, I guess you could say. Because, yeah, it says 1G. Vertical welding progression, not available. And if you look on the WPS, it's not going to give you anything on that either. So the answer is E, all. Do the PQR tests on PQR1 meet acceptance criteria outlined in the BOS? Now the possible answers are tensile test is good, bend test good. Tensile test good, bend test not good. Tensile test specimen 1 good, tensile test specimen 2 not good, bend test good. Tensile test spec 1 not good, test 2 not good, bend test good. Tensile test not good, bend test not good. Okay, so we have our 5 options. So if we go down and we look at our PQR and see how thick is the steel, 1 inch. Now what did I say a couple questions ago? If it's over 3/8 to half an inch, it has to go to side bends. Okay, so and the explanation of this one here, it says 3/4 of an inch. So I believe it depends upon also the type of metal it is. But 5.3.2. Let's see here. Not too far. 5.3, 1, 2. Yeah, guide bend test. 4 side bends or 2 face and 2 root bends. Side bend specimens may be subjected to face or root bend specimens for metal thickness from 3/8 to 3/4, inclusive. For metals over 3/4 of an inch, side bend specimens are required. Okay, so I was wrong on the 1/2 inch, but I was only 1/4 inch off. Don't hate. Just kidding. Again, this is all training. I mean, I'm gonna make mistakes. Shoot, I'm not a professional CDWI yet. I take my first test next week. So 3/4 of an inch. So even though this is right on the 3/4, the tensile test passed. They were supposed to be at 65,000. The lowest one was 65,420. But we go to the guided bend test. It's 1 inch, and they went with the root and face bends. So answer is B. Tensile test acceptable. Bend test not acceptable. I mean, I'm only trying to keep this to half an hour, so I am doing what I can to make it within that time. Let's see. A welder uses WPS flux core arc welding -1 to make a double bevel groove weld using ASTM A516 grade 55 backing material. A 45 degree groove angle, a 3/16 inch root opening. Is this acceptable? Okay, so let's go ahead and look at 1 and 6 here. Oh, excuse me. Oh, all right. So let's go ahead and get rid of the angle at the moment. Just kind of stick it off to the corner. Let's look at all the other stuff that we can, that's all in writing that we could always miss very easily. Backing material. ASTM A36, so yes. 45 degree groove angle. Specimen joint, correct. 3/16 root opening, good to go. Now let's go ahead and bring back that double bevel groove. We look at the sketch. It's 1 angle. It's not a double angle. So this will not be acceptable. As our 5 options were: back material does not match, joint is not acceptable, no groove angle is not acceptable, root opening not acceptable, and yes. As our explanation of the answer is, the only joints allowed are single V groove, single bevel groove, or fillet weld. A double bevel groove is not allowed. Now, on a PQR it says single bevel. We go to a WPS, it states single V groove, single bevel groove, or fillet weld. So it throws all 3 in there. So sometimes one will give you more information than the other. What's here? A welder wants to use PQR1 and FCAW1 to weld a 1.5 inch thick CJP bevel groove weld using ASTM A36 steel, 35 diameter fillet metal, travel speed of 10 IPM. Is this acceptable? So our 5 options are: only if the WPS is revised, no, the base metal is too thick, no, the joint is incorrect, no, the travel speed is too high, no, the base metal type is not allowed. So if we look at it, it's asking for ASTM A36. It's within the parameters. 3.5 diameter fillet metal. It can be revised to do that. Travel speed at 10 inches per minute. This one's 5 to 8. It can be revised. Now we look at our answer explanation, because the answer is A. Only if the WPS can be revised. Each of the variables listed in the question comply with WPS flux core arc welding -1 except for the filler metal diameter. The WPS only allows 0.045 or 0.052. However, the same PQR1 can be used to revise WPS FCAW-1 and incorporate a diameter of 0.035 inches since a change in diameter does not require requalification. And that's pretty much what it says on 5. A change in weld metal thickness beyond that permitted in 5.2.2. So I'll just go back to 5.2.2. It's essentially just that as long as it's recorded in the PQR that it was changed. So, yes, A, only if the WPS can be changed. 16. If a weldment is 4.5 inches thick walls, is heat treatment per document 5, is this acceptable per WPS GTAW-4? Well, as we're now changing documents to number 4 and 5, this is all going to be post-weld heat treatment and treatment intervals and hold times. Well, let's see what it says. It's on 2. Okay, yes it is. Okay, so the heat treatment is 1200 degrees plus or minus 20. Heat treatment hold time is 1.5 hours per inch of thickness, 3 hours minimum. And hold time cooling any except that above 500 degrees Fahrenheit heating or cooling can't exceed 300 degrees per hour. So once it hits 500 degrees, it cannot go above 300 degrees per hour. So our possible answers are no, it does not meet minimum bake out temperature. Yes, it does not exceed the maximum cooling rate. No, this exceeds the maximum base metal thickness range of WPS. No, the temperature is too high. Yes, it receives it for at least 3 hours. Okay, so let's go ahead and think. Did we look at our first piece of paper? We're on the second one. Let's go ahead and take a look at the first one. What is our maximum thickness? It says 4.5 inches thick wall. Well, let's go ahead and take a look at the weld itself. Thickness range qualified, 3/16 to 4 inches. So the question itself exceeds the wall thickness for heat. So the answer is C. No, this exceeds the maximum base metal thickness range of the WPS. Let's go ahead and go on to number 17. Is the post-weld heat treatment heating rate shown in document 5 acceptable per WPS GTAW-4? Okay, well, our 5 options are too short, too long, heating rate is less than 500, heating rate above 500, yes, the heating rate is less than 300 per hour. So remember that anything above 500 degrees has to be a maximum of 300 degrees per hour. If we look at our chart, and with our answer explanation, simply states that the heat treatment section, the maximum heating or cooling rate is 300 degrees per hour if we are above 500 degrees. So let's measure the heating rate above 500. At this time, 540 minutes mark on the document 5, we see that the heating line at approximately 850 degrees. At 600 minutes, mark 1 hour later, we see it at 1200 degrees. That means the heating rate was 350 degrees Fahrenheit per hour. So the answer is D. No, the heating rate above 500 degrees Fahrenheit is over 300 degrees Fahrenheit per hour. Number 18. According to the WPS GTAW 4, at what point would NDT occur using the post-weld heat treatment shown in document 5? Well, our options are between 6 and 800 minutes, 1,110 minutes, 120 to 220, 0 to 20, and between 340 and 400. Well, when we look at our heat treatment section and page number 2, which states at the very bottom, always read your notes. Bake-out process, perform required NDT prior to PWHT, describes above. Before performing NDT, perform bake-out by allowing weldment to cool from inter-pass temperature to 250 degrees. Yeah, 250 degrees or lower. So after you get your little preheat post-weld, you bring it back down, you inspect it, make sure everything's kosher, and then you start the heat treatment to up to the 1200 degrees. And it shows between 340 and 400 minutes is when you're able to check it. Because after you raise it up, then you let it cool down, inspect it, and then let it go back up. So yes. Number 19. If a weldment with 2.25 inch thick walls is heat treated per document 5, does this comply with WPS GTAW 4? So our options are no, time is too short. No, bake out time is too short. Yes, temperature is 1200 degrees Fahrenheit. Yes, cooling rate is acceptable. No, bake out temperature was insufficient. If we look at our deal, so 2.25 hours is 3.375 hours. If you look between 600 and 800, that is only 3.33 hours. So the time was too short, not by much, but it was just too short for the bake out, for the heat treating. So the answer is A. No, the post-weld heat treatment time is too short. Last two here, folks. Suppose the tensile tests on PQ4 are for ASTM A225 grade C base metal that are 3/8 inch in thickness. Do these meet WPS qualification requirements? Now you have, yes, test 1 unacceptable, test 2 unacceptable. Yeah, I'm just going to go back to good and bad. Test 1 bad, test 2 good. Test 1 good, test 2 good. Test 1 bad, test 2 bad. Then not enough information available to determine acceptability. So let's go ahead and take a look at this. The tensile tests for PQR4. It's going to be in document 9. PQR4. These have to break at 110,000 psi. Neither one of these make the mark at 100,250 and 100,060 psi. So both tests are unacceptable. Oh, excuse me. So the answer is A. 21. Suppose the tensile tests at PQR5 are for test weldments includes a 3-inch ASTM grade plate to this grade plate. Are these tensile ASTM A387 Grade 5 Class 2 plate. Are these tensile tests? So, the Grade D plate, the 225, is 80,000 psi. The 387 is 75,000 psi. So, per section 5.4.3.1 states that when testing two metals at different psi tensile strengths, always go to the lesser one. So our test specs are going to be set at the 75,000 mark. And if I go to number 5, we have 80,330 and 79,860. So both tests do pass. Last one. Which tensile test specimen is reported incorrectly between PQR 6, 7, and 8? Well, I actually had just a moment here for you. Oh, excuse me. Oh, that hurts. That hurts. I meant to hit mute and I forgot. My bad, people. My bad. Let's see here. Now, for you to know exactly how much these are going to be, you divide the total load divided by the area. So the ultimate load, or PQR 6, let's just give that one a good example here, is 30,100. You would multiply that, right, the area of 0.576, which comes out to 52,260. Now, when you go to test specimen number 2 of tensile test and number 6, you're going to have 30,400 divided by 0.611, which actually comes out to 49,000. And this is supposed to be set up at like a 50,000. So the specimen fails. As it says in the explanation, the formula for determining ultimate unit stress or ultimate tensile strength is ultimate total load divided by area. If you divide the ultimate total load of specimen 2 and PQR 6 by its area, you get 49,750 instead of the 51,750. As I did every single one, so I was doing 6 different multiplications, and it was the only one that was wrong. So PQR number 6, specimen 2. And with that, I leave you. I hope you was able to get some good knowledge. And this is only the first half. We are only halfway through. I still have more questions to go through on this test B. And there's 3 of them, so it's gonna be 6 parts. Six. So it's gonna be a lot of camera time beyond what I've already done and had screw ups on. And from my web is awesome. It's going to YouTube, and it's just junk, apparently, when it comes to live feeds, to upload, to put videos on. So I'm not going to do that. I'm going to do it this way, so that way I know I got an accurate feed, and my laptop wouldn't pick up sound. So for the person who should I have to actually go through my own. I want to give a shout out to the person who did tell me that did not have sound. I'm sorry, I do not have it. But I have this. I can't load up my YouTube at the moment here. Thank you for telling me it did not have sound. I did notice it that night when I went to review it and listened to it as I slept. And that's what I noticed, and I was so pissed. My wife could vouch. I was pissed. I had to go back to when I had recorded on my phone. I was not happy. But thank you. Y'all carry on. Study hard. And when I pass, you guys pass and everything else, maybe we'll see each other in the field. You just never know. I've been on buildings where there's 3 or 4 CWIs. Not just one. Each company have their own. Like, One would have one for bolting. One would have one for structural steel. They could have been with the same company, but they were specified, trained in specialty for that one piece. So one company, 3-4 different inspectors here, from the concrete to the bolting to the welding. Just imagine you go, which company are you from? I was like, oh, from this. Like, oh, same as him. So, yeah, it's my colleague. I'm like, oh, so we got the whole company here, huh? How about the owner? So, anyway, you guys be safe, be chill, study hard, and I'll catch you on the next video.